Welcome again to Chibuzor Mathphysics, and in today's video I want to welcome you to Eigenvalues and the Eigenvector series, and this will be the last question in this series. Of course, we have several other videos you can watch when it comes to eigenvalues and finding its corresponding eigenvectors. Of course, we are going to continue another series in eigenbases, when you are to find the base of a certain matrix and how you are to compute that and to arrive to some solutions. And that's what we'll be doing in this video. I remain your friend Galagash, and in this video we'll be dealing with question number 4, which is the last question in this paper. Of course, you can watch the previous video so that you know how we do question number 3 to 1. And in this question 4, you have to obtain the eigenvalues and their corresponding eigenvectors. You can observe that in the third question we only found the eigenvalues without its corresponding eigenvectors, but in today's video we are more like finding the eigenvalues and its corresponding eigenvectors. Remain with us as I take you through on how to compute this and arrive at the solution. I remain your friend Galagash. So the first thing we need to do is to have our solution. So our solution, remember that we are to obtain the eigenvalues and their corresponding eigenvectors of this matrix A that is given by 2 by 2, 10, -2, 18, -2. So let us multiply this using the equation A minus lambda I, which must be equal to 0. This must be equal to 0, and we know that if we multiply this by identity matrix, it will be 10 minus lambda -2, then we have 18, then -2 minus lambda, this is -2, and this must be equal to 0. This will implies that we have, if we solve for lambda, we will simply have lambda plus 2, because we have -2 minus lambda can be lambda plus 2, and then we have lambda minus 10. Lambda minus 10. We multiply this, then plus 36. Because we know that -18, it is negative. We have 18 multiplied by 18 multiplied by -2. Multiplied by -2 will give you -36, but we know negative becomes positive, so that's how we get 36 here, and this must be equal to 0, of course. Solving further, this implies that lambda, we can have lambda squared minus 8 lambda when we open up this, minus 20 plus 36 must be equal to 0. This will mean that lambda squared minus 8 lambda plus 16, because -20 positive 36 will give you 16, plus 16 is equal to 0. This is 16. This is plus 16 is equal to 0. So lambda minus 4, and then we have lambda minus 4. We simply factor out these. We look for the cofactors of 8 and 16. 8 and 16, so it is -4, -4, and this must be equal to 0. Or you can plug this in your calculator and find the values for lambda, so that you will see that our lambda 1 will be equals to lambda 2, which means that lambda is equals to 4, and 4 in this case is our eigenvalues. So let us now find the eigenvectors. So since we are having one eigenvalue, so it means we can as well find the one eigenvector. So let us find the eigenvector. Eigenvector for lambda, and lambda is equals to 4. So to find the eigenvector, we have 6 and -2. Let us have 6. We have -2. We have 18. Then we have -6. In case you are wondering where I got 6 from, it is we are replacing, since lambda is equals to 4, so we have 10. So it is 10 minus 4 is 6. We simply have -2, we have 18. -2, -4, we give you -6. So that is how we get this. And this must be equal to some vector C1, C2, some vector C1, C2. We are trying to solve for eigenvectors, and we must equate this to 0, 0, so that we can now solve. So this means that we will have 6C1 minus 2C2, 2C2, and this is equal to 0, because we have 6C1, we have 2C minus 2C2, and in the second equation we can divide this by 3, so that we simply have 3C1, because 3 divided by this will simply give us this, and this will be minus C2, and this is equals to 0. So what will be the value for C1? Let us continue here. We simply have C2, which is equals to 3C1. And this will give us the x value. So the x value in this case, which is a vector, the x value which is a vector will be C1 and 3C1, C1 and 3C1. Of course, what this means is if we factor out 3, we simply have C1. Let's factor out C1, we have 1, 3. So what is the eigenvectors for lambda 4? The eigenvector for lambda 4, eigenvector is equal to 1, 3. And this is how you can solve you can obtain the eigenvalues and its corresponding eigenvectors. I hope you have enjoyed the video. You can catch us in the next video as we continue with finding the bases that have to do with eigenvalues and its corresponding eigenvectors. I remain your friend, Galagash.